Today we're going to talk about exponent power rules. This is building off of multiplication and division. Exponent power rules, they're specific rules for raising exponent powers. And what that looks like, it looks like it's going to be you have a base x taken to the third power, and then usually there's a parentheses or some way to signal that that whole thing is also being raised to another power. Here, the exponent here is 4. So we're going to figure out how to deal with that. Coming up here, here we go, raising a power to a power. So when we're raising an exponent to a specific power, we multiply the exponents. Here we have in the example x raised to the power of a, and that whole thing is being raised to the power of b. Now, what's going to signal the difference there? If we have xa times xb, we know that the base is the same, so that's a plus b for the power. Here, there isn't another base. It's in parentheses and it's being multiplied again. What that's going to look like is here we have color x to the third power, and inside the parentheses we have x to the third, and that is being squared. So x to the third power would be x times x times x, and we have that signaled right here. And if that's happening twice, we can just set that up again, and that's going to be x times x times x times x times x times x. X to the third power squared would become x to the sixth power, which would be the same thing as x to the 3 times 2 power. All right, so try this here below. Let's erase this. X to the fourth power and y to the fourth power are being raised to the second power. So we know that x is being raised to the fourth power, and that's being squared, so we're going to multiply that by 2. Y to the fourth power also by 2. I have to take each of these terms separately. 4 times 2 is 8, so this simplifies to x to the 8th power, y to the 8th power. Okay, power to a power, multiplication. Now, if we're raising a product to a power, product is when two numbers are being multiplied together, or to a number and a letter. So there's multiplication happening. When raising a product to a power, raise all of the factors individually to that power. So here in our burgundy example, x times y is being raised to the exponent of a. So if we were to parse that out, x is raised to the power of a multiplied by y, which is raised to the power of a. You guys do everything inside there. Yeah. Example here, 3 times x to the power of 3 squared. 3 has to be squared times, and then x to the third power times 2. And we talked about that before. We could definitely simplify 3 squared. That's 9. Keep our base. And if x to the power of 3 is being multiplied by 2, this becomes 9 times x to the 6th power. We have to be careful with that. We, in the past, have done a lot of, that's no good. We've done a lot of times where it's like, oh, if you look at example 3 times x to the third, because of PEMDAS, okay, that x is being raised to the third power, the 3 is not. That changes inside the parentheses with this exponent. This exponent is kind of being distributed into both of those things. So let's try it down here below. We have 2 raised to the fourth power, x to the fifth raised to the fourth power, and y to the sixth raised to the fourth power. So let's just kind of parse that out a little bit. So 2 is being raised to the fourth power, x is being raised to the fifth power times 4, and y to the 6 times 4. Oops, 6 times 4 power. 2 to the fourth power is 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So simplify, that would be 16 x to the 5 times 4th power, that's going to be x to the 20th power, and y to the 24th power. So this simplifies to 16x to the 20th power, y to the 24th power. Let's continue on. When we're raising a quotient to a power, it's going to be a division problem, it's going to look like a fraction. When raising a quotient to a power, raise the numerator and the denominator to the power. Just like with the product, we have the two separate terms. Here, we're splitting up those terms again. X over y is being raised to the power of a. That equals x to the power of the a and y to the power of a. In our example, x is being raised to the 3rd power here, y is being raised to the 5th power in the denominator, numerator, denominator, and all of that is being raised to the 3rd power. Simplify, we'd have 3 times 3 on the top and 5 times 3 on the bottom. This simplifies to x to the 9th over y to the 15th power. Okay, let's try it here. 2x squared to the 5th power, y to the 4th. Okay, so the numerator, we know that we have to be careful here. Can't forget about that 2 is being raised to the 5th power, and the x is being raised to the 2nd power times 5, all over, and then can't forget to do the y 4 times 5 down there. 2 to the 5th power, we just did 2 to the 4th power, which was 16. 16 times 2 is 32. X 2 times 5 is 10, and y 4 times 5 is 20. All right, and that is simplified enough. It's a bad one. Oh well. X to the 10th power, 2 times 5. Example 1. We have here 4 times x to the 4th times y to the 7th, and all of that is being squared. So each of these terms is going to be squared, so we get 4 squared. If x to the 4th is being squared, it's going to be times 2. Y to the 7th is going to be times 2 as well. 4 squared is 16. X to the 4 times 2 8th power. Y to the 7 times 2 14th power. Good. And let's head to example 2. 5 times a to the 12th over c, and all of that's being raised to the 3rd power. So let's split up our terms. 5 is going to go to the 3rd power. A, the numerator, 12 times 3. And on the bottom, c doesn't have an exponent there, so we have to assume it's a 1. 1 times 3. Let's see, what's 5 to the 3rd power? 5 times 5 is 25. 25 times 5 is 125, I think. We'll see. A, 12 times 3 is 36. And C times 1 times 3 is the 3rd. Remember, PEMDAS, exponents happen first. We don't do 125 to the 36th power. We don't have to do that. This is a simplified version here. And yeah, we'll practice more in class. See y'all.